Hello, everyone. Welcome to this video on learning mathematics through concepts and examples. In this video, we are going to learn how to solve indefinite integrals. Let's get started. So here I have first two problems. We have to evaluate the following indefinite integrals. So this one, we have to integrate 6x to the 5 plus x plus 1. So I can write it like this. This is integration of 6x to the 5 with respect to x plus integration of x, or you can write 1x with respect to x, and then plus integration of 1 with respect to x. And then this 6 is a constant. We can write as it is. And in order to integrate x raised to 5, we use the power rule. So we increase the power by 1. So 5 plus 1 is 6. And divide by the new power, then plus 1 as it is. So here also we use the power rule. Power is 1. So when you increase the power by 1, that becomes 2. And we divide by the new power, then plus integration of 1 with respect to x is x, because the derivative of x is 1, because integration is the reverse process. We write integration of 1 with respect to x as x. And then at the end, we add the constant of integration. So finally, 6 over 6, that get canceled there. So we get x raised to 6 plus, we have half x squared, 1 over 2, or half x squared, then plus x plus c. Okay, that is the answer to that first question. Now let's look at the second one. So we have to integrate 2 over x plus e to the x. We can also split the integral, just like the way we did in the first one. So we can write it as integration of 2 over x with respect to x plus integration of e to the x with respect to x. I can pull this constant 2 out and rewrite it as 2 times 1 over x dx plus integration of e to the x dx. So 2 is a constant which remains as it is. Now, integration of 1 over x is natural log x, because the derivative of natural log x is 1 over x. But we have to remember one thing here. In case of logarithmic function, the argument, this value, x, must be greater than 0. It cannot be negative or 0. So what we do here is, in order to restrict that, we put the absolute value. So this will be positive. So the integration of 1 over x is natural log of absolute value of x. Then plus integration of e to the x is e to the x, because the derivative of e to the x is e to the x. And at the end, we add plus c. So plus c. Okay, that is the answer to the second problem. Let's move on to next set of problems. Again, we have two questions here. Let's see how we can solve it. So the first one is, I can write the first one like this. This is equal to integration of square root of x means x to the 1/2, x to the power 1/2, and then plus integration of sine x with respect to x. Now, in order to integrate the first one, we use the power rule. That means we increase the power by 1. So half plus 1 is 3 over 2. And we divide by the new power. We divide by 3 over 2. Dividing by 3 over 2 is same as multiplying by 2/3. So I can write here 2/3. And then integration of sine x, if you remember the formula, integration of sine x is negative cosine x. Okay, it is negative cosine x. And at the end, plus c. So that is the answer for this one. Okay, great. Let's move on to this one. Here we have to integrate cosine 3x with respect to x. So if you look at this function, this is a composite function. Your outside function is cosine, and inside function is a linear function 3x. So if you remember what I said in the class, If the inside of the composite function is a linear function, you can use the reverse chain rule to integrate this one. So first, we integrate cosine. Integration of cosine is sine by keeping the inside function same, sine 3x. Okay, because the derivative of sine 3x is cosine 3x. And if you use that reverse chain rule for integration, in a derivative, we multiply by the derivative of inside function. Chain rule for derivative is we multiply by the derivative of inside function. But this is the reverse one. We are doing integration. So we divide by the derivative of inside function. The derivative of inside function, 3x, is a 3. So we divide by 3. And then at the end, we add the constant of integration. And that's your answer. So that is the second set of problems. Now let's move on to third set and see what we have. Okay, here we go. We have the third set of questions here. So if you look at this one, let me write here. We have something like this. Let me first check this one. This is a composite function. X cubed plus 6x is the inside function, and outside function is the square root function. So let me write that part first. Integration of x cubed plus 6x. Now notice this one, x squared plus 2. It is somewhat written in the form of derivative of this inside function. If you think of the derivative of this inside function, derivative of the inside function will be derivative of x cubed is 3x squared, and then derivative of 6x is 6. So this quantity here, x squared plus 2, is somewhat similar to that. You can see that if you multiply this quantity by 3, we get that. This is 3 times more. So I'm not supposed to change the question. I cannot multiply this by 3. So if I'm multiplying, what I need to do is I need to divide by 3 or multiply by 1/3. So by doing that, what happened is we have a composite function with the inside function x cubed plus 6x, and derivative of x cubed plus 6x is also here. If the derivative of the inside function is also there, we use the u substitution. So let's do the u substitution. Let u equal to, and remember, u is always the inside of the composite function, which is x cubed plus 6x. Then if you find the derivative, du will be equal to integration of, derivative of x cubed is 3x squared, and then derivative of 6x is 6, and then dx. In the derivative, we write du over dx. When you move dx over, we get that. Now we make use of this and perform the substitution. So here we are using u substitution to solve this. So this becomes 1/3 integration of this quantity inside the square root is a u. X cubed plus 6x is u. And then square root means power half. And after that, we have 3x squared plus 6 multiplied to dx. And if you look here, 3x squared plus 6 multiplied to dx is a du. So that is du. So this question, which was given in terms of x, is now changed in terms of u. Now we can integrate that easily. 1/3 is a constant. We can keep as it is. And integration of u to the 1/2, we increase the power by 1. So that becomes u to the 3/2. And we divide by 3/2, which is same as multiplying by 2/3, and then plus c. This is the value of the integration, but that's not my final answer because I have to resubstitute the value of u. So here, 1/3 multiplied to 2/3 is 1 times 2 is 2, 3 times 3 is 9. So that becomes 1/9. Okay, 1/9. Value of u is x cubed plus 6x, and then the power is 3/2 plus 2. So we substituted the value of u back here. So that is the final answer to that problem. So what we did is we performed the u substitution and we got the result. Remember, in order to perform the u substitution, what we need is we need a composite function like this, and the derivative of inside function should also be there. In this one, it was not given directly. It was like divided by 3 there. So I use the division by 3 and multiplication by 3 to get that. Okay, let's go to this one. If you look at this one, it also has a composite function. Outside function is square root function, inside function 1 minus x squared. And if you think of the derivative of inside function, derivative of inside function would be negative 2x, but there is only x. So we can rewrite it. We can write it like this. Integration of, we have x over square root of 1 minus x squared dx. The derivative of the inside portion will be negative 2x. So it was negative 2 like that. It should be negative 2x, but this was not there in the problem. I'm multiplying by negative 2. So I also need to divide by negative 2, which is same as multiplying by negative 1/2. So that negative 1/2 multiplied to negative 2 is a 1. So basically that get canceled and it remains just x. And by doing this, we can do the u substitution where u is the inside function. So we can do let u equal to 1 minus x squared. So du is equal to the derivative. Derivative 1 is 0, and derivative of negative x squared is negative 2x. And if we move that dx over, it will be like that. So we make use of that and do the substitution. So let's do the substitution and see what we get. So we have negative 1 over 2, and then integration of denominator is square root of u, and then in the numerator, negative 2x dx. Negative 2x dx is du. So that is a du. And this one look quite familiar. I can rewrite it like this. This is same as negative sign outside. I'm going to multiply. 1 times 1 is 1 over 2 times the square root of u is 2 square root of u du. And that is equal to negative. Integration of 1 over 2 square root of u is square root of u and then plus c, because the derivative of square root of u is 1 over 2 square root of u. That's my answer, but not the final answer. What I need to do is I need to resubstitute the value of u. So this will be negative square root of value of u is 1 minus x squared and then plus c. So that is the answer to this one. Okay, nice. Now let's move on to next set of problems here. So next two problems are here. Let's see. So we are still evaluating the indefinite integral. And if you look at the first one, this is similar to one of the examples we did before. Integration of e to the 2x dx. See, this is a composite function, but the inside function, this one, is linear. If the inside function is linear, you can use the reverse chain rule. So what we do is we find the integration of e raised to something. Integration of e raised to something is e raised to whatever is there. So e raised to 2x. And if you use the reverse chain rule, we multiply by the derivative of inside function. Derivative of 2x is 2. So we divide that by 2. And then plus c. And that is our answer. So that is super simple. Okay. Now let's look at the next one. This has a composite function. You can see, let me write here. We have the integration of cosine x to the 4 plus 5. That is the composite function. Your outside function is cosine. Inside function is x to the 4 plus 5. And if you think of the derivative of x to the 4 plus 5, that is 4x cubed, but we just have x cubed there. It should be actually 4x cubed dx. Then we could have used the u substitution. So that 4 is basically missing. So it's like I'm multiplying by 4. So I also need to divide by 4 to balance that, which is same as multiplying by 1/4. Now I can do the u substitution, where u is the inside of the composite function, or u equal to x to the 4 plus 5. So I can write let u equal to x to the 4 plus 5, which implies if you find the derivative, it will be 4x cubed, move dx over, then it will be dx. So du equal to 4x cubed dx. Now we can do that substitution. And if we perform that u substitution, let's see. 1/4 integration of cosine, that is u, right? X to the 4 plus 5 is u, and 4x cubed dx, 4x cubed dx is du. So the question that was given in terms of x is now changed in terms of u, and we can easily integrate that. 1/4 is a constant. Derivative of sine u, okay? Derivative of sine u is cosine u. So integration of cosine u is sine u, and then plus c, plus c. That is my answer, but not the final answer, because we need to rewrite the value of u, which is x to the 4 plus 5. So this will be 1/4 sine, value of u is x to the 4 plus 5, and then plus c at the end. Okay. I hope you are enjoying the video so far. We are going to solve one more. Okay, let's look at this one. So this one also has a composite function here. I can see that. So let's analyze that. So this is same as, this is equal to integration of, you have sine 2e to the x plus 5. That is the composite function. The derivative of 2e to the x plus 5 will be 2e to the x. It should be 2e to the x. And then we have dx at the end. So that 2 is missing because we only have e to the x. That 2 is missing. So basically, I'm multiplying by 2 there. So I also need to divide by 2. By doing this, we have a composite function where this one is the inside function, and the derivative of that inside function is also here. So we can use the u substitution, where u is the inside of the composite function. So we say let u equal to 2e to the x plus 5. So the derivative du will be equal to 2e to the x dx. So let's make that u substitution. So we get half integration of sine, and then this one is u, and 2e to the x dx, 2e to the x dx is du. So now this complex question reduces to something simple. It is just the integration of sine u. So that is half integration of sine u is negative cosine u, if you remember the formula, negative cosine u plus c. This is my answer, but not the final answer, because I need to resubstitute the value of u. So if I multiply that half with the negative, I get negative half, and then cosine value of u is 2e to the x plus 5, and then plus c. And that is the answer. Okay, I think we practiced enough problems here. So I'm going to end the video here. I hope you find this video helpful. Thank you so much for watching.